algorithms, or how peanut butter and jelly taught me how to program. Okay, so first of all, what exactly is an algorithm? A process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. As per usual, an incredibly helpful definition from a dictionary. Okay, so what exactly does that mean, and what does it have to do with sandwiches? So, like that definition said, an algorithm is a process. It is a sequence of steps that you take to either perform a calculation or solve a problem. You can think of recipes as a very lightweight form of algorithms. So if I was going to list a recipe for a peanut butter and jelly sandwich, it might be along the lines of, get 2 pieces of bread, get your favorite peanut butter, favorite jelly, apply peanut butter to one piece, apply jelly to the other, put them together, and yay, you've got a yummy sandwich. Assuming peanut butter doesn't kill you. But an algorithm would want to go into a little bit more detail. Think about trying to come up with a set of instructions for someone to make a peanut butter and jelly sandwich. And then you're going to give these instructions to the most annoyingly literal person that you could possibly imagine. Yeah, that's algorithms. Get 2 slices of bread? Well, you didn't tell me to open the bag first. Rip it open. Bread all over the floor. Bend down. Pick up 2 pieces. Task complete. So, yeah. And that's what the compiler is going to do, basically. It's going to be annoyingly literal. Another good example of sort of like real world algorithms are Lego instruction sheets. This is, for all intents and purposes, an algorithm. It contains a sequence of instructions, and assuming that you have the necessary pieces, you can perform the steps. Pick up this piece, place it here. Get one of these pieces, put it there. Get 2 of these pieces, put them there. So on, so forth. If you continue to follow this sequence of steps and perform the actions exactly as listed here, you will end up with this little car body every single time that you go through and repeat this. It will be the same expected output every single time. That is, good algorithm development. The fact that Legos are actually such good algorithms is part of the reason why they're so gosh darn popular. I mean, if you think about it, there's nothing here to translate. There's no words. There's no ambiguity. You know exactly which piece you need. You know exactly where those pieces need to go. This is the perfect encapsulation of a real world algorithm. So, how do we go about developing our algorithms? Well, first and foremost, we want to develop algorithms. You almost never want to just sit down and start writing code without a plan. As the overused saying goes, if you fail to plan, you plan to fail, yada yada. If you don't have an algorithm, if you don't have a plan in mind for how you want to accomplish your task, you are just inviting more problems onto yourself than you really need to be doing. Now, there are exceptions to this. Like if I'm exploring a new API, application programming interface, I might not go in with a formal algorithm. I just might go in and start messing around. It's like, okay, well, what if I do this? All right, well, now they know how to do this. What then? Okay, now I'm going to do this thing here, and maybe I'll add this little bit of functionality here. And, at the end, I'll end up with something functional, but pretty much just a kludge of nonsense. And then I'll go back and actually develop algorithms properly for what it is that I plan on doing. But generally speaking, you are going to want to develop the algorithm first. That's just best practices. Now, as far as like actually developing the algorithms, there's 2 core techniques that we're going to take a look at in this course: pseudocode and flowcharts. Pseudocode is the process of mostly formally writing out the steps of the algorithm using programming like language, but you're not adhering to any particular syntax or actual programming language. It's more than just describing it in plain English, but less than writing code, hence the term pseudocode. Flowcharting is the other technique that we're going to take a look at, in which we use symbols to draw out the algorithm to give a bit of a more visual way of tracing the flow of the algorithm. So let's take a look at pseudocode first. So like I said, it's more than just plain English. The plain English description of this is get two numbers from the user, add them together, and display the result to the user. That's the plain English description of what I want to do. That's not pseudocode. You might write the pseudocode for this task like this. Display, enter number 1. Get input from user, store in number 1. Or num1. Display, enter number 2. Get input from user, store in num2. Add num1 and num2, and store in num3. Display, the answer is num3. It's more formal than just simply the plain English description. It's not quite a one-to-one translation of the steps I would need to take to write the code, but it's pretty close. And I'm being very explicit. I'm trying not to compress things too much. Although there is one spot that I did do a little bit too much compression. And that is right here. Display, the answer is num3. And I've left this error in just sort of as an illustration of part of the reason as to why we do pseudocode, which actually is the next slide here. So doing that pseudocode informs me of several things about this programming task. I need 3 variables. So if I go back, I can see that, okay, I'm storing something in a variable here, storing something in a variable here, storing the result in a variable here. So I know that I'm going to need 3 variables. Whatever language this is being written in, I'm going to need to know how to display text. I am also going to need to know how to display text with a variable. And that's actually where the problem comes into play. If we switch back here and we see this display, the answer is num3, it's not very explicitly clear that this is supposed to be a variable here. And so I would probably just put a $sign in front of this to sort of help indicate that, yeah, this is a variable. Or maybe the answer is in quotation mark plus num3 or something like that. Some way of indicating that num3 is supposed to be the value of the variable. It's reasonably clear from here, but there is room for misinterpretation, and we want to avoid that as much as possible when we're writing out our pseudocode. Let's see here. I haven't forgotten any steps. Now, granted, if you're getting 2 numbers from the user and adding them together, it's kind of hard to forget a step there. There's not a lot of steps to forget. But if it's a more complex operation, then being able to carefully step through the pseudocode is an excellent way of making sure that, yes, okay, I have done everything that needs to be done. Any files that I've opened, I've closed. Any resources that I've acquired, I've released, so on and so forth. And also, as a final thing, you can, generally speaking, take your pseudocode, copy and paste into the comments section into your IDE, and it's a guide for your programming. Just comment out the pseudocode so it's not causing compile errors, obviously. And there you go. I've got a little blueprint of all the tasks that I need to do for this. Works out great. So a couple of things to keep in mind when you are writing your pseudocode. Item number 1, it's informal. We're not trying to follow the syntax of the language that you're writing for. In fact, pseudocode generally should be sufficiently language agnostic that you can take that pseudocode and use it with any language. which, again, highly simplistic scenario here. But yes, I can take the pseudocode to any programming language and use this as a guide for this program. There is nothing specific here to Python. You want to be descriptive. It is far easier to reduce or combine steps than it is to try to insert additional steps because you overlooked something. So when you're writing out pseudocode, you want to be really descriptive about what you are doing. Again, think about that annoying person that you gave the peanut butter and jelly sandwich instructions to, because the compiler is that annoying person. Read back through your pseudocode slowly. Think carefully on each step to make sure that you're not making like large sweeping assumptions with a particular operation. Don't be afraid of rewrites. It is far easier, like orders of magnitude easier, to rewrite your pseudocode than it is to debug badly written source code. So if you're reading through your pseudocode and you're just like, you know what, this ain't happening, this is not going to work, just Control A, hit the delete key, and start over. If you're doing it on physical paper, wad it up, toss it in the recycle bin, and move on to a new attempt. It's orders of magnitude better to do that, to rewrite or alter things in pseudocode, than it is to try to debug and change things once you get to the source code step. And then as a final reminder, once you're done with your pseudocode, assuming that it's typed and not handwritten, you can copy and paste it into your IDE to act as notes, comments to help you keep on track for what it is that you need to get done. All right, so that's pseudocode. Let's talk flowcharting. I don't know why I tried to combine the word talk and chart there into the same word, but I did, and we're sticking with it. All right, so flowcharting. Flowcharting is a bit more formal of a process than pseudocode. There is no formally correct way to write pseudocode. It's largely a personal thing. The core thing about pseudocode is consistency. Just as long as you are consistent as you write it, that's sort of like the important part of pseudocode. But other than that, there's no like real hard rules as to what is correct pseudocode. There is most definitely a correct way to draw flowcharts, as we can see from this template diagram here. Now, some of the template items that we have are a bit antiquated, shall we say. You might think the magnetic tape is antiquated, but no, it's still used for very good reason. Magnetic tape is actually one of the best long-term storage solutions that we still have. Like, by orders of magnitude, this is actually legit the best long-term mass data storage medium that we still have, that we currently have. But there's like a very formally correct way to do flowcharting. And now this is a little bit of a disadvantage in that you do actually have to learn all of these symbols here. But this makes up for it in the fact that it becomes easier to share flowcharts, right? It's like everyone knows how to, if you know how to read a flowchart, you can read anybody's flowchart, assuming it was done correctly. And more importantly, it's a lot easier for non-programmers to be able to follow a flowchart than it is for them to be able to follow pseudocode. To an extent, you have to know how to program at a certain level to be able to understand pseudocode. The more complicated the pseudocode is, the more complex your understanding of programming has to be. Flowcharting, not so much. Another thing that flowcharting does better than pseudocode is showing the flow of execution, or sort of like the relationship between when things happen. It's much easier to get that across in flowcharting than it is with pseudocode. So let's take a look at the add two numbers task that we did pseudocode for. This is what you might draw for the flowcharting of it. And so we start off, start symbol, circle, labeled, add two numbers. We flow into the display state, enter number 1. That's what we're going to display to the user. Input symbol. So we're going to get the number, store an X. I used X, Y, and Z just to save on space with this program. Then we're going to display enter number 2. Then we're going to get input, so get number, store in Y. We're going to do a process, add X and Y, store in Z. And then finally display the answer is Z. And again, just by looking at, actually it was doing the flow chart, actually is when I really spotted this here. I'm like, I am definitely combining too many steps right here. Technically speaking, we should have another process step that builds this display string. And then this step here would be displaying the string. And then finally, we come to the termination point. All right, so which one of these is better? Well, honestly, neither. Some people are going to find it easier to skim through the text version, skim through pseudocode. Some people are going to be able to grasp the flow of a program much easier looking at a visual representation like this. It's a little bit of 6 of one, half dozen of another scenario. Now, this flowchart doesn't really show like the strength of flowcharting in trying to keep track of complex interactions, which this, not necessarily great, image does. So the exact context here isn't overly critical. This is a lecture I did on trying to determine the state on an Android device as to whether or not we currently are detecting no touches, one touch, or two touches on the screen, which is a fairly complex thing. It's like we have to query the hardware and do a bunch of checks and detections and things like that. It's a much more complex scenario. So exactly how that flowchart works isn't the point. The point is that it was orders of magnitude easier to flowchart out those processes than it would have been to try to write it in pseudocode, because you really do sort of need to see the flow of going from this state to this process, that process, so on and so forth. And also, like pseudocode, it is way easier to erase a line and move a node than it is to actually just to try to rewrite code. And during that particular process, that was done many times. We'd start tracing through things and go, oh, but wait, we forgot about this condition, or we forgot about this interaction. Erase a node, rewrite it, insert a new node in, redraw the connection circles, and you move on. Versus trying to do that kind of correction in code is obviously not that simple. Okay, so we want to use both. It's not a situation of flowchart versus pseudocode. This is not a binary situation. You frequently will use both. Now, do you start with the pseudocode and move on to the flowchart, or do you start with the flowchart and move on to the pseudocode? Honestly, that's going to depend on what process works best for you. Sometimes I will start with pseudocode, sort of get a rough idea of what it is that I need to do, and then I will move on to flowcharting to make sure that I understand the details and the interactions. Sometimes I'll start with the flowcharting to make sure that I've got a rough idea of like the flow and the interactions, and then I'll move on to the pseudocode to write out the details. It really just sort of depends on the task, and I'll be perfectly honest, sometimes my mood at the moment. But I will almost always use both methods when trying to write complex code. Another thing worth keeping in mind is that there are other aids to algorithm development. specifically patterns and UML. There are more than just that, but those are two major assistants to algorithm development. Patterns in UML are far outside the scope of this course. We will not be dealing with those at all. Just be aware that these are things that exist, and if you continue going down the programming path, you will learn about them. Also, don't be afraid of looking things up. Many different algorithms exist, pardon me, for many different tasks. Use them. You need to sort a list? Well, sorting algorithms, there's lots of them out there. You need to generate a random number? Definitely don't try to develop that on your own. That math is hard. Use an existing random number algorithm. You want to randomly choose from a list of things without creating unintended biases towards the remaining items? There's definitely algorithms for that. Do not be afraid of using existing algorithms. A lot of pain, sweat, and in many cases, really complex math have gone into developing them. And that pretty much covers it. Make sure you watch the follow-up video on how to use Draw.io, which is the software that I use to generate the flowchart. And with that, have a good day, and I'll see you in the next video.